Hello friends, today we are going to solve the question paper on computer programming conducted by APJ Kalam Technological University on September 2020. This is the supplementary paper. This is conducted for the third semester BTech degree examination for electrical and electronics engineering. So the question paper consists of four parts: Part A, Part B, Part C, and Part D. Part C, Part B, Part C, and Part D consists of three questions, each carrying 10 marks. We have one choice question for Part B, Part C, and Part D. If the student answers all three questions in any part, the best of the two answers will be considered. Coming to the Part A, we have 8 questions. Each question carry 5 marks. There is no choice for Part A questions. So the maximum marks is 100 and the duration of the exam is 3 hours. So let us start with the first question. How does x plus plus differ from plus plus x? Explain with suitable example. So this is nothing but postfix increment and prefix increment operator on a variable. So we have in C programming, plus plus operator is called increment operator. It is a unary operator needing only one operand. Hence, plus plus operator can appear before or after the operand with the same effect. So we use the plus plus operator before the variable or after the variable. It has almost the same effect. That means both postfix increment x plus plus, that is the plus plus appears after the variable x, and prefix increment plus plus x will be equivalent. So we have example here, x equal to 6, x plus plus. So if we print the statement percentage d of x, and again another example, x equal to 6, here plus plus x, and printf percentage e of x, both will make the value of x equal to 7. However, when increment expression is used along with assignment operator, then operator precedence will come into picture. So equal to is assignment operator. So we have a expression where the value of x equal to 5 and y equal to x plus plus. So in this we have the operator precedence, that is equal to. So equal to is near to the variable x. So in this case the precedence of equal to is higher than postfix plus plus. That is value of x is assigned to x before incrementing x. So that is here y becomes 5 and x becomes 6. So in the first case y becomes 5 and x becomes 6. In the second example, x equal to 5 and y equal to plus plus x. In this case the precedence of prefix plus plus is more than is equal to operator. So x will increment first and the incremented value is assigned to y. Here x and y both become 6. So to prove this, we have an example program. We have the header file hash include stdio.h. Main function, since we are using the integer type variables, we use int main. Then we have the expression y equal to x plus plus. So in this expression we are using postfix increment. That is the plus plus operator comes after the x variable. Then we have the output statement printf after postfix increment x equal to percentage d and y equal to percentage d x comma y. So in this output statement we get the output as after postfix increment x equal to 6 and y equal to 5, because the precedence is given to the equal to operator. So in the next case we have x equal to 5 and the expression y equal to plus plus x. Here the precedence is given to plus plus because the plus plus is appearing before the value of the variable. So when we give the output statement, that is after prefix increment x equal to percentage d and y equal to percentage d x comma y, the way we get the output statement here as after prefix increment x equal to 6 and y equal to 6, so return 0. So this is the end of the program. So we can execute the program. So after running the program we get the output as given as x equal to 6, y equal to 5, after prefix increment x equal to 6, y equal to 6. So this is the end of the first question. So moving on to the second question. Explain go to and label statements with an example, 5 marks. So go to statement is a unformatted statement, so that is unlike the if else statement. So it has some disadvantages. So a go to statement in C programming provides an unconditional jump from the go to a labeled statement in the same function. So the note is use of go to statements is highly discouraged in any programming language because it makes it difficult to trace the control flow of a program, making the program hard to understand and hard to modify. Any program that uses a goto can be rewritten to avoid them. So this is an unconditional control statement. So the syntax for goto is goto label statement. So here the label can be any plain text except C keyword, and it can be set anywhere in the C program above or below to go to statement. There is a flow diagram for the go to statement. We have a set of statements here, statement 1, statement 2 and statement 3. So we have also the labels for the each statement, label 1, label 2 and label 3. So if we give the command go to label 3, the execution of the program will go directly to the statement 3. So as per the control of the go to statement. Next we have to prove the go to statement, we have the example. So that is we have the comment accept the numbers and reverses it. We have the header file hash include stdio.h. Then we have the main function int main. Then we have the variables required for the reversing the number. So we have the number variable which is used for reading the number entered by the user. We have reverse equal to 0 for saving the reverse of the number. We have a digit for performing calculations, and we have temp underscore num. We have that for storing the variable to do reverse operation. So we have the output statement printf enter the number. Then we have the scanf statement for reading the entered number. So the entered number, for example, if the user enters the number 12345, so that will be stored in the number variable, address of the number variable. Then the number is assigned to the temp underscore number. So we are performing some calculations in the number variable. So that is why the entered number is copied to the temp underscore number. Next we have the go to statement. So we have the start label. Then we have digit equal to number modulus 10. So when we use the digit equal to number modulus 10, so 1, 2, 3, 4, 5, modulus 10 will become, that is the remainder of, modulus 10 will have the remainder of 5. So 5 will be assigned to the value digit. So digit, so in the next step, we have reverse into 10 plus digit. So that will be 0 into 10 plus digit value is 5. So that we will get 5. So 5 is the value of reverse. So reverse has a value of 5. Then we have number equal to number divided by 10. So number divided by 10 will become 1, 2, 3, 4, 5 divided by 10. So that will become 1, 2, 3, 4. So that is the new value of number. So again it will check. So number, if number is greater than 0, so 1, 2, 3, 4 is greater than 0, and this, since this condition is true, it will execute the go to start label. So this is the label which is telling to go to the start position. So again it will reiterate the same steps. So we have again 1, 2, 3, 4 modulus 10, that is equal to 4. 4, that will be the new value of digit. Again we have present value of reverse is 5, that is 5 into 10 plus digit value is 4. So that will become 54. 54 will be the new value of reverse. So again coming to the third step. Third step we have 1, 2, 3, 4 divided by 10. That is divided by 10 is 123. So that is the number. So we again check the condition if number is greater than 0. So 123 is greater than 0. So since this condition is true, again it will say go to start. So it will go to start, and again this we have 123 modulus 10, that is equal to 3. 3 is assigned to the digit. So we have the value of reverse as 54. So 54 into 10. 54 into 10 plus 3. So that we get as 43. So that will be the new value of reverse. So again in the third step we have 123 divided by 10. We get 12 as the value of number. So again 12 is checked with this statement, 12 is greater than 0. So again it will execute the go to start statement. So it will come to the start position and number 12 is divided by 10. So 12 modulus 10 will become 2. So that will be the new value of digit, and 543 into 10 plus 2 will become 5432. So that is the new value of reverse. 12 divided by 10 becomes 1. So that is the new value of number. Again it will check 1 greater than 0. So 1 is greater than 0. Again it will come here, and 1 modulus 10 will become 1. So 1 is the new value of digit. So here we have 5432 into 10 plus 1. 5432 into 10 plus 1 will become 54321. So that is the new value of reverse. But here we have 1 divided by 10. So 1 divided by 10 will become 0.1. So but since we are using integer type variable, that is 0. So number 0 is not greater than 0. So this will come out of this loop and it will execute the printf statement. Input number is equal to 12345 and the reverse number is 54321. So this is the end of the program. So we can execute this program. So it is asking enter a number. I give it as 123456. So input number is 123456 and reverse number is 654321. So we have the next program. Write a C program to find length of a string without using string handling function. So we have to find the length of the string. So we have a string handling function called string length. So it will automatically calculate the length of the string. But without using the string handling function, we have to find the length of the given string. So first we have hash include stdio.h, which is the header file. We have the int main as the main function. We have the string of array. So one dimensional array, which is called str, which is the string. It is a character type array, which is having the size of 100. We have the length is as initialized to 0. So we have to find the length of the string. That is why length is initialized to 0. It is an integer type variable. Again we have the output statement, enter any string. So we have to enter the string that is saved in the address of the str array. So we have the scanf statement, scanf percentages str, and the output statement printf the length of the string is, that is we have the next we have the while loop. So while str of length not equal to /0. So suppose if we enter any string as, for example, any name, so the string will count as 0, e is counted as 1, r is counted as 2, a is counted as 3, l is counted as 4, again a is counted as 5. Then we have the this /0. So this is the last alphabet. So once there is no more alphabets to be counted, so this is the last alphabet. So that is why we have set the while loop as str of length not equal to /0. So it will count and increment the length value until we get the /0 symbol or /0 alphabet. Next we print the length of the string and return 0. So this is the program to find the length of the input string. So we'll execute this program, run it. So it will count the length of the string as 10. So moving on to the next program, discuss the auto and static storage class with an example. 5 marks. So in this we have 4 types of storage classes: automatic, static, extern, and register. So in this question they have asked for giving the explanation for automatic and static variables. Both are similar and have a small difference. So automatic variables are always declared within a function and are local to the function in which they are declared. That is, their scope is confined to that function. Automatic variables defined in different functions will therefore be independent of one another, even though they may have the same name. Any variable declared within a function is interpreted as an automatic variable unless a different storage class specification is shown in the declaration. So that is, we have a example program here. So that is, in this example program, so we have automatic variables declared. Any variables is considered as an automatic variables. unless it is specified as the static or extern or register, which comes before the data type of the declaration. So in this example, we have the header file hash include studio.h main function. Then we have the automatic variable a. So a is the, in this example, a is the automatic variable. So that is a is assigned to the value of 10, and we have the index variable I. So the both the variables are of type integer. Next we have the output statement percentage %d plus plus a. So we are giving the prefix increment to the value of a. So this is in the main function. So after the two statements, we have the again another statement that a equal to 20. So we had initially given the value of a as 10, and now we are assigning the value of a equal to 20. Then after that we have the for loop for I equal to 0, I less than 3, I plus plus. So it will increment the index variable up to 3. So next we have the output statement print of percentage %d a. 20 will be printed 3 times since it is the a local value of a. So in this block we have the value of a as 20, and above the program, in the beginning of the program, we had defined a as 10. Again we close this loop. So we have a equal to 20 till this block. So this highlighted block is having that a is having carrying the value of 20. So after this again we have the printf statement percentage %d a. So again here it will print the value of this value. So it will print a equal to since we have incremented here, the present value of a is increased to 11. So it will printf percentage %da. So it will print a as 11. So this is the end of the program. So we will execute this program. So this is the program. So we are proving that in the automatic variable, the scope of the variable is defined only in either the function or in the main program. Next we run this program. So here we have, so we can, since it is coming in the same line, we can give the slash new line. So again we run the program. So the value of 11 is from this printf statement. So we have incremented the value of a. So it is giving the showing the value of a as 11. And we are using, since we are using the for loop for I equal to 0 to 3, so it is printing the value of 23 times. So here we have initialized the value of a as 20. Again we have in the last printf statement the printing the value of a as 11. So this is clearly explaining the scope of the variable a. That is, automatic variable will have the value in the either in the main program or in the function. Thank you for watching our channel. If you have not subscribed to our channel, please subscribe the channel and press the bell icon. Thank you. Next part, that is static variable. So static variable is also similar to automatic variables, but once the static variable is defined, the value of the static variable will be the same throughout the life of the program. So even if the function is exited and re-entered after some time, the value of the variable will not change. So in a single file program, static variables are defined within individual functions and therefore have the same scope as automatic variables. That is, they are local to the functions in which they are defined. Unlike automatic variables, however, static variables retain their value throughout the life of the program. Thus, if a function is exited and re-entered at a later time, the static variables defined within that function will retain their former values. This feature allows functions to retain information permanently throughout the execution of the program. Static variables are defined within a function in the same manner as automatic variables, except that the variable declaration must begin with the static storage class designation. Static variables can be utilized within the function in the same manner as other variables. They cannot, however, be accessed outside their defining function. So this is similar to the automatic variable, except that the the value of the static variable will be permanent throughout the life of the program. So along with when we define the static variable, we mention the keyword static before the data type while declaring the variable. So we have the example program. So we have the header file hash include studio.h. We have the function named fun, which is the type integer. We have a variable count. So before going to the function, we will first explain the main part of the program. We have the main function. We have a static integer named count. So count is initialized to 0. So the value of count is declared as 0. So it is a static type of variable. Then we call the function through the printf statement. So we are printing the value of count by calling the function. So we are calling the function two times. So when we call the function the first time, so it will go to the function part. So in the function, the value of count is taken as the formal parameter. So it is sent from the actual argument here in the main program to the subprogram as formal parameter. And here in the function, we are incrementing the value of count to +4. So we are adding 4 to the value of count, and it is assigned to the value of count. So it will return the count to the main program, and it is printed here. So the first time count is called, it will go and print the value of count as 4. The second time it will go, the function will again, it is called, and it will again print the value of count as 4. So because it is a static variable, the value of count is taken as 0. So we'll execute this program. So in this program, so first time the count is called, it is increased the value of count to 4. Again we call the function again. It is taking the static int value of count as 0 and incrementing the value of 4 and returning it as 4. So it is not taking the value of count as changed to 4. So this is the example of static integer, static storage class. So next program is question number 5. Explain following terms associated with a pointer. Number 1, chain of pointers. Number 2, pointer expression. And number 3, scale factor. So it is for 5 marks. So first let us see what is chain of pointers. It is possible to make a pointer variable to point to another pointer variable, thus creating a chain of pointers. For example, in the following program, the pointer variable ptr2 contains the address of the pointer variable ptr1, which points to the location that contains the desired value. This is known as multiple indirections. So a variable that is a pointer to a pointer must be declared using additional indirection operators, symbols in front of the name. The declaration int as star star ptr2 tells the compiler that ptr2 is a pointer to a pointer of integer type. Remember, the pointer ptr2 is not a pointer to an integer, but rather a pointer to an integer pointer. We can access the target value indirectly pointed to by pointer to a pointer by applying the indirection operator twice. So this is the explanation of pointer to a pointer. So to know the working of pointer to a pointer, let us see the example program. Hash include studio.h. We have the main function. Then we have the variable, which is the integer type. It is initialize the value of, it is assigned the value as 50. So the value of x is 50. Then we declare a pointer variable ptr1. So that is pointing to the address of x. So the ptr1 contains the address of variable x. Again we declare another pointer to a pointer variable. So this ptr2 is a pointer to a pointer ptr1. So PTR2 contains the address of PTR1. So that is pointer 2 contains the address of pointer 1. So when we print the star PTR1 equal to percentage %d star PTR1, so actually we are using the star operator to access the content of the variable x. So that will using the star operator we can take the value held by the variable x, so that is 50. Again, if you use star ptr2, star ptr2 contains the value held by the variable x. So ptr1 ptr2 star ptr2 can access the value held by the variable that is pointer ptr. So this is the end of the example. We'll execute this program. So when I run this program, star ptr1 equal to 50, star ptr2 equal to 50, because x equal to 50. Suppose I change the value of x equal to 60 and run the program. The value of star ptr1 equal to 60 and star ptr2 equal to 60. Continuing the next part, pointer expression. Pointers are used to point to address the location of a variable. So a pointer is declared by preceding the name of the pointer by an asterisk symbol. We have the syntax data type star pointer underscore name. When we need to initialize a pointer with a variable's location, we use ampersand sign and before the variable name. So pointers are used to point to address the location of a variable. A pointer is declared by preceding the name of the pointer by an asterisk. When we need to initialize a pointer with a variable location, we use the ampersand sign before the variable name. So to explain that, we have the example. So we have the comment here, declaration of integer variable. So where var is the variable that is assigned a value of 10. So it is of integer type. We are then initializing the pointer variable. So pointer variable is mentioned as a star before the name of the variable. So star pointer, that is equal to address of variable. You can define star pointer equal to address of variable. The ampersand and is used to get the address of a variable. So we can directly find the location of any identifier. Directly find the location of any identifier by just proceeding with an ampersand sign. So in this example, this code prints the address of x. So we have the header file, then the main function. We have the integer variable x equal to 10. So this for just for printing the address of x. So address of variable x equal to percentage %p and ampersand x. So it will give the value of the address. So we can just test by running the program. Address of variable x equal to, it will give the value of address. Part is scale factor. So in the case of primitive types, adding 1 to a variable results in incrementing its value by 1, and subtracting 1 to the variable results in decrementing of its value by 1. Since a pointer is not a normal variable, adding 1 to the pointer results in the next variable's address. Subtracting 1 to the pointer results in previous variable's address. Now we will observe the same with an example. Say, for example, a series of 3 variables of short type are declared and a pointer is stored with the address of a variable. As an explanation, so we have 3 variables a, b and c, and we have the pointer variable to c. So we have the value of a as 10, b as 20 and c as 30. The address of a is 5524, address of b is 5522 and address of c is 5520. So all the 3 variables are of integer type. So we have the pointer p pointing to the variable c. So it is containing the address of the variable c. So it is holding the value 5520 and it is pointing to the variable c. Short p equal to address of c. So a equal to 10, b equal to 20 and c equal to 30. So here p is the pointer to the variable c holding the address of c 5520. Now p plus 1 gives the address of next variable b 5522 and p plus 2 gives the address of next variable a 5524. So unlike a normal variable which is incremented, suppose if a is a normal variable, so if a equal to 6 and if I increment a plus 1, so it will give the value of a equal to 7. but it is different in case of pointer variable. So if I increment the value of p plus 1, it will jump 2. So it will go to the address of b. So that is 5522. So if I add p plus 2, so it will jump 2 times and it will go to the address of a, that is 5524. To prove that, we have the example program. So that is hash include stdio.h main function, and we have the three variables declared as short a equal to 10, b equal to 20, and c equal to 30. So short means the integer type which carries 2 bytes for each variable. Again we have the pointer to the variable c, so that is star p equal to address of c. Then we are printing the value of address here, p equal to percentage u p, and again p plus 1 percentage u p plus 1, and p plus 2 percentage u p plus 2. So this will complete the program. So when I run the program, we should get the value of p as 5520, p plus 1 equal to 5522, and p plus 2 equal to 5524. But the value of address will vary depending on the compiler used for executing the C program. We are copying and running the program. We have the output as p equal to some value 82. So we can just see the last four digits, 6882 and 6884, and p plus 2 equal to 6886. So this is the working of scale factor. So by this we understand that the value of a short pointer increments by 2 on adding 1 to the pointer. If we take a float pointer, then increments by 4 on adding 1 to the pointer. So if we take the float pointer, it will add 4 to the previous address. So we have a similar example to the previous one. So that is include stdio.h header file. We have the main function here. So we have three variables a, b, and c having floating point numbers. So here a is having the value of 10.54, b equal to 20.44, c equal to 30.657. So all three variables are of type float. So we have a pointer variable of type float. So it is pointing to the variable c. So pointer p is carrying the address of variable c. So then we print the value of p here in this and p plus 1 in the next output statement, and p plus 2 in the next output statement. Then we complete the program. So here, since we are using float type of variable, pointer variable, so it will increment by 4 bytes. We will execute and run this program. So instead of the integer type data like the previous program, we are using float type data. So run this program. So when we see the output, P last four digits 1372, 1376, and 1380. So it is incrementing the address value by 4 bytes. So if we conclude the above observation, short pointer increments by 2 on adding 1, float pointer increments by 4 on adding 1, and character pointer increments by 1 on adding 1. That is, pointer is incrementing by its type size on adding 1. Scale factor is the quantity of increment in the value of a pointer on adding 1. So this is the definition of scale factor. So we have the summary of the table here. Data type is short int, that is 2 bytes, scale factor in byte. The quantity of increment in the value of a pointer on adding 1. So integer type will be either 2 or 4. Character type data is 1 bytes. Float is 4 bytes, and double is 8 bytes. Moving on to the next question. Question number 6. Write a C program to find the largest element in an array using pointer. So we have to find the largest element in the array. So that is, so we have the output here to explain. So it will ask to enter the number of elements. We give the number of elements. Any number decided by the person running the program. So it will ask to enter the number of elements one by one. So we enter the 7 elements here, and it will, out of the 7 elements, it will check and find the highest element in the array. So we will do the program part. So first we have the header file hash include stdio.h hash include conio.h. Before that we have the comment C program to find the maximum element of each row in an array. So in this example we have maximum element in an array. So we have the function part. So function part we can see later. First we will explain the main part. So we have the main function integer m. So we have the integer m here and integer I comma j. So we have m is the number of elements. So how many elements we want to find the how many elements we want to enter in the array, that is m. So we have index variable I and j. So I and j is used to find the maximum element in the array. So these both are index variables. We have array 1 of 10. So we can enter a maximum of 10 numbers in the given array. So it is asking to enter the number of elements. Then we enter the number of elements and it is stored in the address of m through this scanf statement. Then it is asking to enter the elements of the array 1. So we enter the elements of the array 1 using the for loop. For I equal to 0, I less than m, I plus plus. So we enter how many elements are to be entered in this program. So it will be stored in the address of array of I. Next, it is calling the function maxi underscore row. So maxi underscore row is the function used to find the maximum element of the array, and it is passing the entire array as actual argument. So array 1 is the actual argument and m is also the actual argument. So array 1 is the entered array and m is the number of elements in the array. So this is passed as actual argument and it will go to the function part as formal parameter. So here we have scrolled up to the function part. So here we have maxi underscore row is the name of the function. It is having the formal parameters array of 10, arr of 10 and integer m. So these both are declared inside the function as integer type variables. Next we have the index variable I equal to 0 and j. Then we have initialized the value of max equal to 0. So first we have to consider the value of the maximum value, the maximum element in the array is 0. Next we define a variable result of m. So result of m is another array that will have the order of the given array. So next it will have the while loop while I is less than m. So then we'll execute the for loop. For j equal to 0, j less than m minus 1, j plus plus. So value of j equal to 0, j less than m minus 1, j plus plus. So if array of I is greater than max. So suppose if we enter some values as given in the array as in this example. So in this example we have array of I greater than max. So first element is checked with the maximum value. So maximum value is 0. Then we know that it is true. So it will change the value to the maximum value. So this 2565 will be the new value of maximum value. So next it will be 2565. So next it will check the second element with the maximum value. So this maximum value, if it is true, it will change the value to 9635. Again it will check the condition. So this I is incremented every step. So after checking the first index value, so if it is true, it will change the value. Again it will go to the second position. So I plus plus will go to the second position and check. So this condition is also true. It is changed to change the value to 9635. Again it will increment the value of I and it will go to the this position. So since this array of I is not greater than max, so this value, so 145 is not greater than 9635. So again it will move to the last position and exit from the loop. The highest element in the array is percentage %d max. So since the value of max is assigned as the second number 9635, it will print the value of max as 9635. This is how the program is executed. So we'll scroll and run the program. run this program. It is asking to enter the number of elements. I give it as 7. Enter the elements of array 1. So 22, 56, 87, 96, 54, 102, 546. So highest element in the array is 546. So moving on to the next program. Distinguish between following functions. 1. GetC and getChar. Number 2. Printf and fprintf. Number 3. feof and ferror. So it is having 5 marks. So first one is getC and getChar. The key difference between getC and getChar is that the getC function, getC is used to read a character from an input stream, such as a file or standard input, while getChar is to read a character from standard input. getC. This function returns the character read as an unsigned character constant to an int or EOF on end or file or error. So for example is the following example shows the usage of getC function. So to prove the usage of getC function, we have the program here. Hash include studio.h, main function, character C, output statement, enter the character, standard input statement, that is getC stdin, that is assigned to the value of C, then character entered, that is put C, output statement unformatted, put C std out, return 0. So when we run the program, it is asking to enter a character. So we enter a character, it will be printed in the output. So it is asking to enter a character, I enter it as W. So it will enter character entered is equal to W. So next we have the get character, get ch here. The C library function int getChar void gets a character and unsigned char from stdin. This is equivalent to getC with stdin as its argument. Thank you for watching our channel. If you have not subscribed to our channel, please subscribe the channel and press the bell icon. Thank you. getChar. The C library function int getChar void gets a character and an unsigned character from stdin. This is equivalent to getC with stdin as its arguments. Next we have declaration. Following is the declaration for the getChar function. Int getChar void. This function returns the character read as an unsigned char cast into an int or EOF on the end of file or error. So the example of getChar is the following example shows the usage of getChar function. Header file studio.h, main function, variable of type character, output statement printf, enter character. So getChar will be read into the variable C. Printf character entered prints the character using putchar and return 0. So when we run this program, enter a character, I type it as yes. So it's giving character entered is 5. Next is printf and fprintf. The difference between printf and fprintf is that in C programming language, printf function is used to print the character, string, float, integer, octal, and hexadecimal values onto the output screen. We use printf function with %d format specifier to display the value of an integer variable. Printf and fprintf can be used according to the task. So example of fprintf. Printf character is %c, new line ch. Printf string is %s / new line str. So we get output as character is a and output as string is high. So this is alphabet character is a. Next is fprintf. Fprintf is used to print content in file instead of std out console. Syntax is int fprintf file star fptr constant char star str comma and so on close brackets semicolon. Example of fprintf. C program for the above approach. Hash include studio.h header file int main function integer I comma n equal to 2 character str of 50. So we have an array of type character consisting of size 50. We have a variable initialized to 2 and I is the index variable. Open file sample.txt in write mode. File star fptr f open sample.txt write mode. If fptr equal to null, could not open file, return 0. For I equal to 0, I less than n, I plus plus. Puts says enter a name, scanf percentage in brackets caret symbol slash new line percentage star c str. Next, fprintf fptr percentage d percentage s slash new line I comma str. Fclose fptr return 0. So this program is just telling the difference between the fprintf and fprintf. So printf is used to give the output in the output console. This is the output console. Fprintf is nothing but it will give the result in the another text file. So this is the program. So we'll run this program. Copy, paste. So it is asking to enter a name. I enter it as Kerala. Enter. It is asking enter a name. Kerala. And I type it as type escape. Enter. So it has opened a file named sample.txt. And it has in the 0th line, it has first line it has entered as Kerala and the second line it has entered as Kerala University. So this is the example for printf and fprintf. So after completing the entering the output, we have to type the escape symbol. So next is the FEOF and ferror. FEOF function. So it checks the ending of a file. It continuously returns 0 value until the end of the file does not come and returns a non-zero value when the end of the file comes. So the syntax of FEOF is FEOF file pointer semicolon. Example of the FEOF is file pointer star FP. If FEOF of file pointer is equal to 0, printf not EOF when end of file not come, or if FEOF of file pointer not equal to 0, printf end of the file end comes. So next is ferror. It checks errors in a file during the reading process. If error comes, if error returns non-zero value, it continuously returns 0 value during the reading process. Syntax ferror file pointer. Example ferror fp that is equal to 0. Printf reading if ferror fp not equal to 0, printf error close bracket. The difference between the functions. First is getC and getChar. Second is printf and fprintf. Third is FEOF and ferror. So this is the question number 7 for 5 marks. Next we have the question number 8. Explain the following control statements in Python. For loop. Second one if else. Also write their syntax. 5 marks. So first we have the for loop. The syntax for loop is, so for the item in list, that is action, as usual the action consists of one or more statements all at the same indentation level. These statements are also known as the body of the loop. The item is a variable name and list is a list. Execution of the for loop works by setting the variable successively to each item in the list and then executing the body each time. Here is a simple example. The comma at the end of the print makes all the printing occur on the same line. So that is for I in 2, 4, 8, 0, close bracket, colon. Print I, comma. This produces the output 2480. Next is if, elif, else. More complex decisions may have several alternatives depending on several conditions. For these, the elif is used. It means else if, and one can have any number of elif clauses between the if and the else. The usage of elif is best illustrated by an example. If x greater than or equal to 0 and if x less than 10, digits equal to 1. Elif x greater than or equal to 10 and x less than 100, digits equal to 2. If elif x greater than or equal to 100 and x lesser than 1000, digits equal to 3. Elif x greater than or equal to 1000 and x lesser than 10,000, digits equal to 4. Else digits equal to 0, hash more than 4. In the above, the number of digits in x is computed so long as the number is 4 or less. In the above, the number of digits in x is computed so long as the number is 4 or less. If x is negative or greater than 10,000, then digits will be set to 0. We have completed part A. Next, we are moving on to the part B. Thank you for watching our channel. If you have not subscribed, please subscribe the channel and press the bell icon. Thank you. Next we move on to the part B. Part B, question number 9A. List the different operators in C. Discuss about conditional operator. This is for 5 marks. So we have C operators can be classified into following types: arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, conditional operators, and special operators. So we have been asked to explain the conditional operator. So moving on to the conditional operator. The conditional operator in C language are known by two more names, that is ternary operator and question mark operator. It is actually the if condition that we use in the C language decision making. But using the conditional operator, we turn the if condition statement into a short and simple operator. The syntax of a conditional operator is expression 1 question mark expression 2 colon expression 3. The explanation is expression 1 is evaluated. It will result either in true or false, and if the result is true, expression 2 is considered, and if the result is false, expression 3 is considered. So the explanation here, the question mark in the syntax represents the if part. The first expression 1 generally returns either true or false, based on which it is decided whether expression 2 will be executed or expression 3 is executed. If expression 1 returns true, then the expression on the left side of colon, that is expression 2, is executed. If expression 1 returns false, then the expression on the right side of colon, that is expression 3, is executed. As we can see here, there is a colon here. So if the expression 1 is true, the expression 2 on the left side of the colon is executed. And if the expression 1 is false, the expression 3 that is on the right side of the colon is executed. Thank you for watching our channel. If you have not subscribed, please subscribe the channel and press the bell icon. Thank you. Number 9B is draw a flowchart to check given number is palindrome or not. So that is for 5 marks. So we have the flowchart here. In the beginning of the start, we are including the header files. Then we in the next step we declare the variables, numbers, that is for entering the given the number to be reversed. In the next step, we copy the number to be reversed to another variable called temp. So in the end, we compare the reverse number and the value entered copied in the temporary variable, so that we can check whether it is a palindrome or not. Next, we initialize the value of reverse to 0. So reverse is another variable that is used for making calculations to reverse the given number. In the next step, the number is evaluated whether it is equal to 0 or not. If the number is not equal to 0, then we do the perform the following calculations. The number is divided by 10, that is number modulus 10, and the remainder is copied to the remainder variable. In the next step, the reverse into 10. So initial value of reverse REV is equal to 0, 0 into 10, that is equal to 0, plus remainder value will be equal to 5. In the next step, the given number 1, 2, 3, 4, 5, that is divided by 10, and the divided value, the divisor value is copied to the number variable. So so that we can see in the above example. So we have the number here. So the given number is 1, 2, 3, 4, 5. So it is divided by 10, that is modulus of 10, that we get the value as 5. So 5 will be the value that is copied to the remainder variable. So in the next step, we have reverse equal to reverse into 10 plus remainder. So we know that the value of initial value of reverse is equal to 0. So 0 into 10 plus 5 will be, that is 5 is the value of reverse. So we get the value of reverse as 5. In the next step, we have 1, 2, 3, 4, 5 divided by 10. That will be equal to 1, 2, 3, 4. So 1, 2, 3, 4 is the value of number. So again, this after the value of number is changed to 1, 2, 3, 4. It will again check in the above condition if the 1, 2, 3, 4 is equal to 0. So since it is not 0, it will again come back to the next step. So that is the 1, 2, 3, 4 is divided by 10. The 1, 2, 3, 4 modulus 10 will be equal to 4. That is copied to the value of remainder. Then in the next step, the reverse into 10. The value of reverse is 5. 5 into 10 plus remainder is 4. So we get 54 as the value of reverse. Here 1, 2, 3, 4 divided by 10, we get 1, 2, 3 as the new value of number. So when we see here in the next step, we have 1, 2, 3, 4, the modulus 10, that we get 4 as the remainder. Here in the previous step, we had got 5 as the value of reverse. 5 into 10 plus 4, we get 54 as the value of reverse. Here we get 1, 2, 3, 4 divided by 10 as 1, 2, 3. So again 1, 2, 3 is passed to the higher conditional statement. So 1, 2, 3 is greater than 0. So again it will come back to the next step. So in the next step, 1, 2, 3 modulus 10 will be that is equal to 3. 3 is the remainder. Here we have 54. 54 into 10 plus 3, that we get as 543 as the new value of reverse. In this step, we have 1, 2, 3 divided by 10. We get 12 as the value of number. So again, when it goes back to the higher previous condition, so 12 is not equal to 0, it will again come back to the this block. So here again we have 12 modulus 10 will be equal to 2. So 543 into 10 will be equal to 10 plus 2 equal to 5432. That is equal to reverse. 12 divided by 10 is equal to 1. So 1 is the new value of number. So 1 is equated in this condition. So 1 is not equal to 0. Again we have to do this operation. So 1 modulus 10 is equal to 1. So 1 is the new value of remainder. We have 5432 into 10 plus 1. We have 54321 as the value of reverse. So again we have 1 divided by 10. 1 divided by 10 we get 0.1 as the value of number, that is equal to 0 as we are using integer type variables. So again in the next step it is checking whether the number is equal to 0. So as the number is equal to 0, it will come out of the loop. So it will check if the entered number is equal to the reverse. So we see that the 1, 2, 3, 4, 5 is not equal to 5, 4, 3, 2, 1. So it will print as number is not a palindrome. Suppose if we enter the given number as 1, 2, 1. So if we enter the given number as 1, 2, 1, then the reverse number is also 1, 2, 1. then we can find that the number is a palindrome. This is how the program works. Moving on to the next question. Question number 10a. Railway department charges are given below. Distance in kilometers. Up to 30 kilometers, rate per kilometer is rupees 5. 31 to 50 kilometers, rate per kilometer is 8 rupee 25 paisa. Greater than 50 kilometer, rate is 10 rupees. Senior citizens age greater than 60 are given a concession of 30% on the fare. Write a program to print the details of a passenger's name, age, distance traveled, and the ticket fare. So we are moving on to the program. Program is, first we have the header files. Hash include stdio.h, hash include stdlib.h, hash include string.h, and hash include cornio.h. We have declared a structure. So the name of the structure is passenger. So we have the members as name of the passenger, name of maximum 20 alphabets. So that is the size of the character is 20. So next we have integer type variable for giving the age of the passenger. Next we have the distance traveled by the passenger in kilometers. Then we have the ticket fare. So that is a float type variable, because we have to enter the rupees and paisa. So that is the float structure. We have the array of structure. So that is the we are declaring for the number of passengers. So we can enter up to maximum of 60 passengers. That is why we have declared a array of passengers. Next we have the main function, and we have index variable for counting the passengers and n for entering the number of passengers while running the program. We have the output statement, enter the number of passengers. So for entering the number of passengers, we have scanf %d ampersand n. So this will read the number of passengers entered for running this program. In the next step, we have the output statement, enter the name of the passenger, age of the passenger, and distance traveled by the passenger. So next, we have the for loop for entering the passengers. So as we are using the array of structure, we have to enter, suppose we enter 5 passengers, we have to enter all the details for all the 5 passengers. That is name of the passenger, age of the passenger, and distance traveled by the passenger. So in this input statement, we have %s, %d, p of I dot name, and p of I dot age, and p of I dot distance traveled. Next we have for loop for checking the condition. So this is the for loop for all the passengers. For I equal to 0, I less than n, I plus plus. If p of I dot distance traveled is less than or equal to 30, p of I dot ticket fare, that is equal to 5. Next, else if p of I dot distance traveled greater than or equal to 31 and p of I dot distance traveled lesser than or equal to 50, p of I dot ticket fare, that is equal to 8.25 rupees. Else p of I dot ticket fare equal to 10 rupees. Next we have for I equal to 0, I less than n, I plus plus. P of I dot ticket fare equal to p of I dot distance traveled into p of I dot ticket fare. This will give the amount as per the distance traveled by the passenger. We are given a table. So up to 30 kilometers, passenger is charged 5 rupees per kilometer. In between 31 to 50 kilometers, the passenger is charged 8 rupees 25 paisa, and greater than 50 kilometer, the passenger is charged 10 rupees per kilometer. And also there is a condition: if the age of the passenger is greater than or equal to 60 years, he will be given a concession of 30% on the fare. So we have in the program we have already entered the details of passengers and the number of passengers. Next, we had also given the condition as per the distance traveled and calculating the fare. Next, we are giving the condition that if p of I dot age is greater than or equal to 60, p of I dot ticket fare equal to p of I dot ticket fare minus 0.30 into p of I dot ticket fare. That is the amount 30% of the amount is deducted from the ticket fare of the passengers who are aged equal to or greater than 60 years. Next, we print the output statement. The details of passenger ticket is given below. For I equal to 0, I less than n, I plus plus. So we are printing out all the details of all the passengers. That is name, age, distance traveled, and the ticket fare. So it is the output is as per the age and distance traveled by the passengers. So that is we are printing the ticket fare as per the distance traveled and the age of the passengers. So this is percentages slash t. This slash t is used for a tab space between the given members. Next we have percentage d slash t, percentage d slash t, and percentage 0.2f slash t. Next we have the p of I dot name, p of I dot age, p of I dot distance traveled, and p of I dot ticket fare. Then get character. So this is the end of the program. So we'll just scroll the program. We'll execute this program. So it is asking to enter the number of passengers. I give it as 6. So name of the passenger is first Baba. Age of the passenger is 65 years and the distance traveled is 25 kilometers. Next we have Binu. Age of the passenger is 25 years. Distance traveled is 22 kilometers. Next we have Raju. Age of Raju is 20 years. Distance traveled is 45 kilometers. Next we have Balu. His age of Balu is 72 years. Distance traveled is 50 kilometers. Next we have Dinu. Age of Dinu is 12 years. Distance traveled is 125 kilometers. Next we have Naveen. Navee's age is 82 years. Distance traveled is 1000 kilometers. When we enter, we get the output as we can see that Baba has got a concession of 30% and also Navi has got a concession of 30%. Here also we get Balu. Balu 72 years has got a concession of 30%. So also we can see that as per the distance traveled, so less than 30 kilometers they are being charged 5 rupees. Baba has got concession, so that is why it is showing 87.50. Binu has traveled 25 kilometer at the 22 kilometers at the rate of 5 rupee per kilometer. So he's been charged 110 rupees. So moving on to the next question. Question number 10b. What is the difference between compiler and interpreter? Thank you for watching our channel. If you have not subscribed, please subscribe the channel and press the bell icon. Thank you. Next question is question number 10b. What is the difference between compiler and interpreter? That is for 4 marks. We have a table here for explaining the difference between the compiler and interpreter based on the following factors. 8 factors. Based on the 8 factors, we have the difference between the compiler and interpreter. Input. Based on the input, it takes the entire program at a time. The compiler takes the entire program at a time for translating. The interpreter takes a single line of code or instruction at a time. The output of a compiler is it generates immediate object code. That is, the compiler takes the entire program and translates into machine language. The interpreter does not produce any intermediate object code. Working mechanism. The compilation is done before execution. The interpreter compilation and execution takes place simultaneously. The speed of the compiler is comparatively faster. The speed of the interpreter is slower compared to the compiler. Memory. Memory requirement is more due to the creation of object code in compiler. In the interpreter, it requires less memory as it does not create intermediate object code. Errors. The compiler display all errors after compilation, all at the same time. The interpreter displays error of each line one by one. The detecting the errors in compiler is difficult compared to interpreter. It is easier comparatively to detect errors in interpreter. Pertaining programming languages are in compilers C, C++, C hash, Scala, TypeScript uses compiler. The interpreter uses PHP, Perl, Python, Ruby as a interpreting language. Moving on to the next question. Question number 11. Write a C program to find the solution of a quadratic equation, real and distinct, equal or complex roots, using switch construct. Draw the flowchart also. Thank you for watching our channel. If you have not subscribed, please subscribe the channel and press the bell icon. Thank you. We'll see the program. So this is the comment: C program to find all the roots of a quadratic equation using switch case statement. Next we have the header files: hash include stdio.h, hash include math.h. Next we have the main function. Then we declare three variables a, b, c. Or a, b, c are the coefficients of the quadratic equation. So we know that the quadratic equation will be of the general form ax square plus bx plus c equal to 0. So for that purpose we are declaring three variables to store the coefficients of a, b and c. Then we declare two uh, variables of float type. We have root 1 and root 2, the roots of the quadratic equation, and also we have another variable called imaginary, and also we have another root variable called discriminant. So root 1, root 2, imaginary and discriminant are all of type float. Next we have the output statement: enter values of a, b, c of quadratic equation ax square plus bx plus c. Next we have the read. For reading the input a, b and c, we have percentage %d, percentage %d, percentage %d, ampersand a, ampersand b and ampersand c. This is for reading the coefficients of a, b and c. Next we are calculating the discriminant value. So we have the formula discriminant equal to b square minus 4ac. So that is given by b into b minus 4 into a into c. Next we find the roots of the quadratic equation based on the nature of the discriminant. So first we use the switch statement if the discriminant greater than 0. So if the discriminant is greater than 0, we execute the case 1. So in the case 1, discriminant is positive. So root 1, we have the formula minus b plus square root of discriminant by 2 into a. And the value of root 2 will be minus b minus square root discriminant by 2 into a. Then it will print the value of the discriminant. Printf: two distinct and real roots exist, percentage %2f and percentage %2f, root 1 comma root 2, and break. So this break statement is used to exit from this case and go to the end of the program. Next we have the case 0 where discriminant is not positive, that is the value of the discriminant is lesser than 0, that is discriminant value is negative. So we use the case 1. If the discriminant is negative, we have the value of root 1 equal to root 2 equal to minus b by 2 into a, and the imaginary part, that is equal to square root of minus discriminant by 2 into a. Then we will print the value of the root 1 and the imaginary. Two distinct complex roots exist, percentage %2f plus I percentage %2f and percentage %2f minus I percentage %2f, that is root 1 imaginary comma root 2 comma imaginary. So the both the roots will be having real and imaginary parts. Next we have the break statement to exit from the case 1. Next we have the case 0 if the discriminant is 0. the value of the discriminant is 0, then we get root 1 equal to root 2, that is equal to minus b divided by 2 into a. Then it will print the value of root 1 and root 2. Two equivalent real roots exist, percentage point 2f and percentage point 2f root 1 comma root 2. Then it will give the break statement. Then it will close the brackets and it will end the program. We'll just scroll the program here. We'll execute the program, run the program. We have two examples. In example 1, 2x square minus 5x plus 3 equal to 0. Here the value of a equal to 2, b equal to minus 5 and c equal to 3. So we should get x equal to 3 by 2, that is equal to 1.5 and 1. So we get 2 minus 5 and 3. So we have got the expected answer, that is x equal to 3 by 2 and 1.0. So 3 by 2 value is 1.50. We again run the program. So we are executing the second example, that is x square plus 4x minus 5 equal to 0. So a equal to 1, b equal to 4 and c equal to minus 5. So running the program, a equal to 1, b equal to 4 and c equal to minus 5. So the roots are 1 and minus 5. So we are getting 1 and minus 5 are the roots of x. Next we move on to the sub question, that is we have to explain the flow chart. So in the flow chart we have the start for the header files and their main function. Then we have the declaration of coefficients a, b and c. After that we have to find the discriminant, that is using the formula b square minus 4ac. Then we move on to the switch statement. We have the switch statement for the three conditions, that is discriminant is greater than 0, discriminant is equal to 0 and discriminant that is less than 0. Then we have the explanation for that. Root 1 equal to minus b plus square root of discriminant by 2 into a, root 2 equal to minus b into square root of discriminant by 2 into a, and it will display the roots. The roots are real and different, and it will display the root 1 and 2. Then we have the second case, that is discriminant equal to 0, root 1 equal to minus b by 2 into a, root 1 equal to root 2, and it will display that roots are real and equal, and it will display the value of root 1 and root 2. Then the third part, that is real equal to minus b by 2 into a, imaginary equal to square root of discriminant by 2 into a, and display the roots are imaginary, display real plus imaginary I, and display real imaginary I. So this is the flow chart. So we have completed the part B. So next we move on to the part C. So that is question number 12a. Write a C program to read a matrix A and find the product of A into A transpose. So it is for 8 marks. First we have to find the transpose of a matrix. Then we have to find the product of the matrix and the transpose of the matrix. So we have the program here. We have the header files, hash include stdio.h, hash include conio.h. Then we have the main function. We are declaring two-dimensional array A consisting of 10 into 10, and we have another two-dimensional array called B, which is having the size of 10 into 10. That is, we have one more two-dimensional array named C having the size of 10 into 10. So we have, as we have declared the two-dimensional array, we are also declaring the index variables I, J and K for the row operation, column operation, and for multiplication of the two matrices. And also we have the row and column. So row and column is for the order of the matrix. Next we have the output statement, enter the rows and columns, and we have the input statement scan of percentage D, ampersand row and ampersand column. Next we have the output statement, enter the elements of the matrix. Then we have the nested for loop. So whenever we read or print any matrix, before that we have to use a for loop. So in case of two-dimensional arrays, we use nested for loops. So we have for I equal to 0, I less than row, I plus plus, and for j equal to 0, j less than column, j plus plus. After that, we have the scanf statement percentage %d and b of I of j. So that is the matrix that we are going to enter and find the product of matrix, product of the matrix and the transpose of the matrix. Then again we are copying the entered matrix to another matrix. So that is, as we have to find the transpose of the given matrix, we are copying the given matrix to another variable a. So we are using the nested for loop. For I equal to 0, I less than row, I plus plus. For j equal to 0, j less than column, j plus plus. And we are copying the contents of b of I of j to a of I of j. So a of I of j consists of the actually entered matrix. Then we are finding the transpose of the matrix. Printf transpose of the matrix A is for I equal to 0, I less than row, I plus plus, printf slash new line. For j equal to 0, j less than column, j plus plus. Then with the printf statement, we are printing the transpose of the matrix. So that is A of j of I. So once if we write A of j of I, it will print the transpose of the matrix A of I of j. Next, we have to find the product of the matrix A and the transpose of the matrix. That is, we are having the nested for loop. For I equal to 0, I less than row, I plus plus. For j equal to 0, j less than column, j plus plus. And C of I of j equal to 0. So since we are finding the transpose of a matrix, we have to multiply the rows and column of. Suppose in this example, we have two matrix. So that is, we have to multiply 1 into 1 plus 2 into 2 plus 3 into 3. And it will become the one element of the matrix. That becomes 14. Next element is 1 into 4 into 1 plus 5 into 2 plus 6 into 3. That becomes the second element, 32. The third element is 7 into 1 plus 8 into 2 plus 9 into 3. That becomes 50. Similarly, we have to multiply other elements also. So for that purpose, we are using the variable k, index variable. So k equal to 0, k less than row, k plus plus. Then this formula is very important. C of I of j equal to C of I of j plus A of I of k into B of j of k. So this is used for multiplying the matrix A and its transpose. That is, C of I of j equal to C of I of j plus A of I of k into B of j of k. Then after that, we have to print the product of matrix A, that is A into transpose of matrix. For that, again we are using the nested for loop. For I equal to 0, I less than row, I plus plus, printf slash new line. For j equal to 0, j less than column, j plus plus. Printf slash t is for the tab space between the two elements. So it is slash t percentage d and C of I of j, close bracket. So this is the end of the program. So this is a sample output. When the output statement is enter the rows and columns of matrix A, we give it as 3 and 3. Then enter the elements of the matrix. So for the example, we are giving as 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it will find the transpose of the matrix 1, 4, 7, 2, 5, 8, 3, 6, 9. After that, it will find the product of the matrix A and its transpose. So this is the final multiplication of the final product of the matrix A and its transpose. So we can test this output. So before that, we'll just scroll the program. So we'll run this program. Run the program. Enter the number of rows and columns. I give it as 3 and 3. Enter the elements of the matrix. I give as 1, 2, 3, 4, 5, 6, 7, 8, 9. So next it will find the transpose of the matrix. Transpose of the matrix is given here 147, 258, 369. After that it will find the product of the matrix and its transpose. This is the final product of the matrix and its transpose. So this question is for 8 marks. Next 12b, discuss any two string handling function. So that is for 2 marks. So string handling functions are defined in include string.h. So there are about 10 string handling functions. The first one is strcmp. So it is for comparing the two strings, and it will as per the ASCII comparison, that is American Standard Code for Information Interchange, and returns one of the three values: -1 if the first string is lesser than the second string, and if both the strings ASCII value is equal, it will return 0, and if the first string ASCII value is greater than the second string, it will return as +1. So that is, it will compares the two strings character by character ASCII comparison and returns one of the three values. The syntax is strcmp string 1 comma string 2, where string 1 and string 2 are one-dimensional array of characters. If the return value is -1, the ASCII value of the first string is less than the second string. If the return value is 0, both the string are equal. If the return value is +1, the ASCII value of the first string is greater than the second string. There is an example here. So we have the variable p equal to strcmp abc, capital ABC comma small abc. Here the ASCII value of capital A is 65 is less than small a, that is 97. Small a ASCII value is 97. Thus the above statement returns -32, that is 65 minus 97, and is assigned to p. So the difference is assigned to p. Second string handling function is strcpy. strcpy function, it copies the one string to other string. So in this syntax we can see strcpy string 1 comma string 2 semicolon. The example is strcpy lotus comma jasmine. So here the jasmine will be copied to the lotus. The contents of lotus will be lost. Third string handling function is strcat. strcat is used to concatenate two strings. So it appends one string at the end of the specified string. Here the syntax is strcat string 1 comma string 2. String 2 is appended to the end of string 1. So in this example, strcat programming comma language. The resultant string will be programming language. Thank you for watching our channel. If you have not subscribed, please subscribe the channel and press the bell icon. Thank you. Next question is question number 13a. Write a C program to print first n Fibonacci series Fibonacci numbers using recursive function. So this is for 5 marks. So this is the comment of the program to print Fibonacci series using recursion. Next we have the header file, include stdio.h, hash include conio.h. Then we have the function declaration or function prototype. So Fibonacci is the name of the function, and int n is the formal parameter. So it is of type integer. Then we have the main function. Then we are declaring the variables n and count. Count is an index variable that is used for counting the numbers up to the limit, and n is the limit, actually the number of Fibonacci numbers to be printed, or the limit of the Fibonacci numbers. So we have the output statement, enter the number of terms in the Fibonacci series. Then we have the scanf statement, that is for inputting the limit, %d %n. So the limit or the number of terms is printed on the saved on the address of n. Then we have the output statement, Fibonacci series till n is the number of terms needed. Then we have the for loop, for count equal to 0, count less than n, count plus plus. and we have the output statement. So inside the output statement we have the recursive function Fibonacci of count. So here count is the actual argument. So count is starting from 0 up to the limit. Suppose if we give the value of n as 10, so we want to find the Fibonacci numbers up to the 10th limit. So n is 10. So we are starting the count from 0. So in the first iteration, the count is 0. The actual argument that is in the count is 0. The value in the count is 0. So once this recursive function is called, it will go to the function here, the function to calculate the nth Fibonacci number. So here it is having a formula, like it is having a formula, a Fibonacci of n equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. So I will explain the working of getting the Fibonacci numbers after this explanation. First we will see how the function works. First the value of count is copied to the function. So that is a recursive function in as a formal parameter. So n is a capital N is the formal parameter. So it is also of type n, integer. It is also of type integer. Then it will have a terminating condition n less than 2. So if n is the value of n is less than 2, it is a terminating condition. It will return n. So here the 0 is less than 2. This condition is true. So 0 will be returned to the main program. So main program will print the value of 0 here. Again, the count will increment the value by 1. So since we are having the value of since we are incrementing the count by 1, so the value of count becomes 1. So from 0 to it will become 1. Next again this recursive function is called. So count will send the value of 1 to the function here. So n is accepted in this function and it will again check this condition. 1 is less than true, 2 is true. So 1 is less than 2 is true. So it will return the value of 1 to the main function. So again 1 is printed after 0. Next it will again increment the value of 1 by 2. Now the present value of count will be 2. So again 2 will be sent to the recursive function. Now recursive function will check whether 2 is less than 2. So this condition is false. 2 is not less than 2. So it will go to the next condition. So in the next condition, Fibonacci of 2 minus 1 plus Fibonacci of 2 minus 2. So here the working here is the working of the function. So suppose if we give the limit of Fibonacci as 6, then we count from 0. So the present value of count is 0. 0 is less than 2. So return n. It returns the value of 0 and it will be printed in the first position. Then count plus plus increments the value of 0 to 1. When count value is 1, 1 is less than 2, that is the terminating condition. Again it will return n, that is returns 1 and it will be printed in the second position. Again count increments the value to 2. When count equal to 2, 2 is not less than 2, that is why it will go to the next condition. Control goes to the else part. So it will return Fibonacci n minus 1 plus Fibonacci n minus 2. That is Fibonacci 2 minus 1 plus Fibonacci 2 minus 2. So Fibonacci 2 minus 1 is, we know, it is equal to 1 and 2 minus 2 equal to 0. So the next term will be 1. So 1 will be printed in the third position. So again count plus plus increments the count to 3. So when count is equal to 3, we know 3 is not less than 2. So it will go to the next part, next statement, that is Fibonacci of n minus 1 plus Fibonacci of n minus 2. So Fibonacci of that is 3 minus 1 and 3 minus 2. So 3 minus 1 is 2. 2 and 3 minus 2 is 1. So we have Fibonacci of 2 is 1 and Fibonacci of 1 is 1. So we get 2 as the answer. So we have Fibonacci of 1 here and Fibonacci of 2 here. So we get 2 as the answer. The value of 2 will be printed on the fourth position. Count plus plus increments the count to 4. Next, when count equal to 4, we have the condition 4 is not equal to not less than 2. 4 is not less than 2. So control goes to the else part, next part. So it will return Fibonacci n minus 1 plus Fibonacci n minus 2. That is Fibonacci 4 minus 1. So 4 minus 1 plus Fibonacci 4 minus 2. We know that value of Fibonacci 3 is 2 and the Fibonacci 2 is 1. So we get 3. 3 will be printed on the fifth position and the count will be incremented by 5. It will increment to 5. So when count is equal to 5, 5 is not less than 2. Control goes to the next part. Fibonacci 5 minus 1 plus Fibonacci 5 minus 2. So we know Fibonacci of 4 equal to 3 and Fibonacci of 3 equal to 2. So 5 will be printed on the sixth position. So count plus plus, count increments to 6. So and so on, we get the remaining parts. So it will, whichever number is given as the limit, it will keep printing up to the that limit. So again, when count is equal to 6, if 6 is not less than 2, control goes to the next part. Fibonacci 6 minus 1 plus Fibonacci 6 minus 2. We know Fibonacci 6 minus 1, 5 equal to 5 and Fibonacci 6 minus 2, 4 equal to 3. So 8 will be printed on the seventh position. So count is again incremented to 7. So in the when count is equal to 7, count 7 is not less than 2. Control goes to the next part. It will return Fibonacci 7 minus 1 plus Fibonacci 7 minus 2. So that is, we know Fibonacci of 6 is 8 and Fibonacci of 5 is 5. So we get the total as 13 here. So value 13 will be printed in the sorry 8th position. So and so on, it will print up to n. So we'll just scroll this program. We'll run this program. So it is asking enter the number of terms in the Fibonacci series. So I can give any number of terms. Suppose if I give 15, so it will print the series up to 15. So the Fibonacci will work based on the first two numbers are 0 and 1. Always the Fibonacci is the first two numbers are 0 and 1 and the next number will be the addition of the first two numbers. So in this case, we have 0 and 1 in the beginning and the third number will be the addition of the first and second number. So 0 plus 1 equal to 1 and again the fourth term. Fourth term is the addition of the second and third term. So we have the fourth number 1 plus 1 equal to 2 and again the fifth term is the addition of third and fourth term, that is 2 plus 1 equal to 3. Again the sixth term is the addition of fourth and fifth term, that is 2 plus 3 equal to 5. And the seventh term 8 is the addition of fifth and sixth term, that is 3 plus 5. And the eighth term 13 is the addition of sixth and seventh term, 5 plus 8. And the ninth term, that is 21, that is the addition of seventh and eighth term, 8 plus 13 equal to 21. This is how the Fibonacci series works. So moving on to the next question. Question number 13b. Explain the differences between pass-by value and pass-by reference with the help of example. Arguments are sent to the functions and their values are copied in the corresponding function. This sort of information exchange between the calling function and the called function is known as parameter passing. There are two methods of parameter passing. One is call by value. The second one is call by reference. First we will see call by value. When the values of arguments are passed from calling function to a called function, these values are copied into the called function. If any changes are made to these values in the called function, there is no change in the original values within the calling function. To illustrate this, we are doing a program to prove the call by value method. So program illustrates the call by value parameter passing mechanism. We have the header file hash include stdio.h. We have the main function. Next we have the two variables n1 comma n2, that is for entering the storing the numbers entered. Next we have the variable x. So we want to find the sum of the two numbers. So we are sending the value of n1 and n2 to the function, and we are adding the numbers and returning the sum to the main program. So we have the function named call by value. This is the function prototype. So uh, we are declaring the function prototype. The name of the function is call by value. Then we are initializing the value of n1 equal to 6 and n2 equal to 9. Then we will print the output as n1 equal to %d and n2 equal to %d. That is, before the function call, the value of n1 equal to 6 and n2 equal to 9. Then we call the function. The function is called call by value. So call by value function is called n1 and n2 are the actual arguments. That is, we are sending the values from the calling function. So main program is the calling function. So n1 and n2 are the actual arguments. So once we call the function, so it will go to the function part. So here function, in the function part, P1 and P2 are the copies of N1 and N2. So N1 is the copy of, P1 is the copy of N1 and P2 is the copy of N2. So P1 and P2 are the formal parameters. So we declare the value of P1 and P2 as integer variables. So by giving the data type as int. Then we declare the sum. So the sum is like we have x equal to the value of x. Sum is the copy of x, because we want to find the value of sum of P1 and P2. So we have sum equal to P1 plus P2, adding the value of P1 and P2 to the sum. Next we change the value of P1 to P1 plus 2. So P1 plus equal to 2 means the meaning is, so we are adding P1 plus 2 and assigning the value to P1. So again P2 equal to P2 equal to P2 into P1. P2 equal to P2 into P1. So this value is also copied to, so we are changing the value of P1 and P2. So next it will print in the function P1 equal to %d and P2 equal to %d P1 comma P2. So the value of P1 and P2 will be, so in this case we have declared N1 equal to 6 and N2 equal to 9. So when we pass it to the function, so when we get it here, it N1 equal to 6 and N2 equal to 9. So P1 equal to 6 and P2 equal to 9. 9 plus 6 here, 9 plus 6 equal to 15. In this case, P1 plus P2 equal to 6 plus 2. 6 plus 2 equal to 8. That is equal to P1. New value. Next case, P1 equal to 8. So in the previous step, we had changed the value of P1. So this value will be put here, P1, and into P2 will be 9. That is equal to 8 9s are 72. So that is equal to P2. But it is the value in the function. So it is the value in the function. Then we return the value of sum. So when the sum is returned, it will go to the main function and it will be stored in the x. So when we print it here, n1 equal to %d and n2 equal to %d, n1 comma n2. So we are printing the value of n1 and n2. There won't be any change. The value of n1 will be 6 and n2 will be 9. It is not 8 and 72, because it is the copy that we have passed to the function, and when whatever change happens in the function will not be reflected in the calling function. So main program is the calling function, but the value of sum will be 15. So we have returned the value of sum here. The sum will be 15 because we have not assigned any value to the value of x in the main program. So this is how the program works. So when we execute the program, we get this statement here. So printf n1 equal to 6 and n2 equal to 9. So this statement is this one, and the second statement is this one. P1 equal to 8 and P2 equal to 72. So this is the second statement. Third statement is this, n1 equal to 6 and n2 equal to 9. This one, and x equal to 15 is the this output statement. So there is no change in the values of n1 and n2 before and after the function is executed. So we will just scroll the program. So we will execute this program. After executing the program, we get the output as shown in the screen. Next we move on to the call by reference. Actual values are not passed, instead their addresses are passed. There is no copying of values since their memory locations are referenced. If any modification is made to the values in the called function, then original values get changed within the calling function. Mechanism by which pointers can be passed as arguments to the functions. Thus, the data items of the calling program can be accessed by the called program function. No value is copied when pointers are passed as arguments, as in the call by value method. Unlike call by value method, if the values are changed in the functions, this will modify the original contents of the actual parameters. When the pointers are passed as arguments, then the following 2 points must be considered. In the calling program, the function is invoked with the function name and the addresses of actual parameters enclosed within parentheses. That is, in the call by reference, we are passing the address of the actual arguments. That is ampersand var1, that is variable 1, and ampersand variable 2. That is the address of variable 1, variable 2. So in the call by reference function, we are passing the address of the variables. That is variable 1 and address of variable 1 and address of variable 2. So if there are n variables to be passed, up to n variables. So in the called program, that is in the function parameter list, each and every formal parameters pointers must be preceded by an indirection operator asterisk or star. We will, when we see the program, we will have more clarity. So first, in this program illustrates the call by reference method to interchange the contents of two integer variables. That is, we are trying to prove that whenever a change is made in the called function, the changes will reflect in the calling function also, because we are passing the address of the variables in the main program. So that is, we have this is the comment. We have the hash include stdio.h header file. Then we have the main function. We have two variables declared as num1 and num2, representing the number 1 and number 2. Then we have the function prototype, that is interchange. Interchange is the name of the function, and we have two formal parameters n1 and n2. These are pointers to the numbers num1 and num2. We have the pointer operator here, asterisk. Then we have the output statement, enter the two numbers. We have scanf %d and num1 and num2. So and num1 is the address of the number 1, and num2 is the address of number 2. The two entered variables or entered numbers are saved in the num1 and num2 addresses. Next we have the output statement, print of num1 equal to %d and num2 equal to %d before calling the function num1 comma num2. So suppose if we enter the value of num1 as 100 and num2 as 200, so it will print as num1 equal to 100 and num2 equal to 200. Then we call the function interchange, and it will pass the, instead of passing the actual values or the actual variables, it will pass the address of the num1 and num2. So this is the function call. So we are calling the function here. So the address of num1 and address of num2 is passed as actual arguments to the main to the subprogram. So once we call this function, so the control passes to the function part, function to interchange the values of two variables using pointers. So here we have the pointer. So pointer variable n1 and n2 as the formal parameters. So the formal parameters n1 and n2 will hold the address of the num1 and num2. But using the star operator, we can access the content of num1 and num2. So we are using another temporary variable of integer type. Then we interchange the contents of n1 and n2 using temporary variable. So we are transferring the value of n1 to temporary variable and n2 to n1. So once the content of n1 is passed to the temporary variable, n2, the value of n2 is copied to n1. Then the value of temporary variable is copied to n2. Hence, the value of n1 becomes 200 and the value of n2 becomes 100. The two numbers are interchanged. Thus, we can say that through the call by reference method, we can change the value of the actual arguments. So we'll when we run this program, so it is asking enter the two numbers we have given as 56 and 88. So when we execute the first printf statement, that is num1 equal to 56 and num2 equal to 88 before calling function, and when we pass the same to the function and print it, so we get as printf num1 equal to 88 and num2 equal to 56 after function is called. So that is because we have changed the content of n1 and n2 using the temporary variable, as we had passed the address of the variables to the function. So this is the example of call by reference method. We'll scroll this program. We'll execute this program. We can change the main to int main. So it is asking enter the two numbers. I give it as 45 and 96. So it will say num1 equal to 45 and num2 equal to 96 before calling function, and num1 equal to 96 and num2 equal to 45 after function is called. So this is the difference between pass by value and pass by reference. Next question number 14. Write a C program to read the array elements and to sort them in ascending order. Use functions to read, sort and print the array. So we have to read the array elements and sort them in ascending order using functions. So we have to use three different functions for reading the elements, sorting the elements and printing the elements. So we have the program here. We have the header file hash include stdio.h, hash include conaio.h. We are declaring the array of 100. So we are this is the function part. We are declaring the array of 100, I comma j comma n as the index. I and j are index variables. N is the limit. So suppose we want to sort 10 numbers, so the value of n will be 10. So the requirement, as per the requirement of the program, we are giving the value of the n. Then we have the temporary variable for sorting operation. Then we have this function void read. So this read is the one function, print is another function, and prepare is one more function. So for printing the sorted array, we have one more function here. So before going to the explaining the function, I will first start with the main program. So main, we have the main function here. Then we have the output statement, enter the size of the array. So we can enter up to 100 elements. So for this program, we have to enter the size of the array. That will give the scanf %d ampersand n. Suppose I want to sort 7 elements in the 7 elements. Then I give the value of n as 7. So the 7 will be stored in the address of n. Then we call the functions one by one. First we call the read function. Then we call the print function, then prepare function, then print array function. So first it will read the elements entered one by one. So in the read function, we enter the elements, that is any random element 95, 62, 15, 42, 2, 74, 33. So all these elements are read in the read function. First we go to the read function. It will pass the limit as the actual argument. So first going to the read function. So we have the read function here. So in the read function, the small n is called the uh, formal parameter. Formal parameter, it is declared as integer type. Then we have enter the elements one by one with space. So we have to enter the elements one by one with space. So for I equal to 0, I less than n, I plus plus. So we have the index variable and for loop for reading the elements one by one. Then we have the scanf statement, percentage %d ampersand array of I. So we have we have to read the elements one by one as given in the array. Thank you for watching our channel. If you have not subscribed, please subscribe the channel and press the bell icon. Thank you. In the read function, we have n as the formal parameter. Then we have the output statement, enter the array elements one by one with space. So we have to enter the array elements one by one. With the for, we have the for loop with an index variable for I equal to 0, I less than n, I plus plus. We have again the scanf statement will read the entered array elements. So it will be stored in the address of the array element, address of the array and all the elements will be stored. So this is the read function. So this is the read function. Then we it will go back to the main program, and next is the print function. So n is the actual argument. So next we go to the print function. So in the print function, it will print the entered array elements once. So which we had entered, it will be reprinted again. So in the print, so n is the formal parameter. It will it has the output statement. Entered array elements are, we have the for loop for I equal to 0, I less than n, I plus plus. Printf percentage %d slash t array of I. So it will print the entered array element once. Again we have the third function, that is prepare of n. Prepare of n is for sorting the array element. So sorting as per the ascending order. So n is the actual argument here. So again we go to the prepare function. So n is the formal parameter here. Next we have for loop. So for I equal to 0, I less than n, I plus plus. For j equal to I plus 1, j less than n, j plus plus. So we will take this example itself. So we want to sort the array in ascending order. So suppose if this is the entered values, so we want to first I equal to 0. First number is I equal to 0. So 0th position is 95 and I plus first position is 62. So j is the 62 and I is 95. Then we have the condition array of I greater than array of j. So this condition is true because 95 is greater than 62. We have to sort the array in ascending order. The lower number has to be on the left hand side and the higher numbers has to be on the right hand side. So we have to interchange this using temporary variable. So 95, array of I 95 is copied to the temporary variable, and array of I plus 1, that is array of j 62, is copied to the position in the array of I, and again the content in the temporary variable is copied to the array of j. So 95 and 62 will be interchanged. So here we get 62 and the second position will have the term 95. So again the value of I is incremented. So it will go from here. The value of I will become 1 and the value of j will become I plus 1. So value of j will become 15 and the value of I will become 95. Again it will check array of I is greater than array of j. This condition is true because 95 is greater than 15. So the value of 95 is copied to the temporary variable and the value of j, the 15, is copied to the position in 95. And the value in the temporary variable, that is 95, is copied to the next position, array of j. So 95 and 15 will be interchanged. So 15 will go to the second position and 95 to the third position. So this will happen in all the elements. So in this fashion, all the elements will be interchanged. So 15, when we sort the elements, all the elements will be sorted in the ascending order. So after the sorting is completed, it will have to print the sorted array. So for that we have another function called print array. So n is the actual argument here. N is the actual argument. So next we go to the print array function. In the print array function we have n as the formal parameter. Then the print array will print the sorted elements one by one. So the sorted array elements is given below. For I equal to 0, I less than n, I plus plus, printf percentage %d slash t array of I. The slash t is the tab space for printing with the space. So we will scroll this program once. We'll execute this program. So it is asking to enter the size of the array. The size of the array I give it as 8. I have to enter 8 elements randomly. So 200, 64, 82, 12, 6, 74, 95 and 30. So it will first print the unsorted elements as it is, and after that it will sort the elements and it will print the sorted elements. So once it will enter all the entered elements with the tab space, after that it will sort the elements and print it. So moving on to the next program. So we have completed part C. Now we have part D. So part D, 15 question number 15. A student database stores the following information about students in a class: roll number, name, gender and CGPA. Write a program to prepare a rank list based on CGPA. Also prepare a list of students having CGPA less than 7. So this question is for 10 marks. So we have to write a program to prepare the students as per the CGPA, that is the roll number of students, name of the student, gender of the student and the percentage of marks, that is CGPA scored by the student. And also we have to prepare a rank list of students having CGPA less than 7. So we have to out of the entered list of students, we have to prepare a list, two lists. We have to prepare one list of rank students from highest to the lowest. Also we have to prepare another list of students having the CGPA less than 7. So going to the program, so we have the header files hash include stdio.h, hash include conio.h. We have declared a structure named student. So it will have the members as roll number, name of 20 size, gender of 20 size. So it can be male or female. So it has a maximum of 20. We have also CGPA of type float. So this is the structure of name student having the members roll number, name, gender and CGPA. We have flag equal to 0 and index variable I, j, n. So n is the number of students. So we can declare the array of structure, that is struct student s of 20. So s of 20 is the array of structure. So we can enter maximum of 20 students. So n is the limit. When we run the program, we can execute while we are executing the program, we can enter the number of students as 10 or 15 based on the requirement. Temp is for sorting the students marks. So based on the CGPA and preparing the rank list, we can use temp for sorting the students marks. Then we have the main function here. Then we have the output statement, enter the number of students. Then we have percentage %d scanf ampersand n. So it will read the limit in the address of the variable n. Then we have function read, function prepare and print rank list, and prepare B7. So that is below 7. So there are 4 functions. First we go to the function read. So n is the actual argument here. So n is the number of students which is passed onto the function read. So n is the formal parameter here. We have the output statement, enter the roll number, name, gender, CGPA. Then we have the for loop for I equal to 0, I less than n, I plus plus. We have the scanf statement, that is percentage %d, percentage %s, percentage %s, percentage %f. That is for reading the roll number, name of the student, gender of the student, and the CGPA. So it will store the roll number, name, gender, and CGPA for all the students up to the limit n. After that, we go to the next function, prepare n. So we have to prepare the rank list. So for prepare n, we are again having the n as number of students, formal parameter. Then we have the for loop for I equal to 0, I less than n minus 1, I plus plus, and j equal to I less than n, j plus plus. This is for sorting the rank list based on the CGPA. So we have the condition, if s of I dot CGPA is less than s of j plus 1 dot CGPA, temp equal to s of I. So suppose we have entered the CGPA of students as 5.5, 6.4, 7.2, like that. So we have to have the highest ranking student first and the lowest ranking student in the last. So we have to interchange the contents. So that is 7.2 has to appear in the first and 5.5 has to be in the last. So for that purpose, we are using the sort operation using temporary variable. So we have the condition here, if the first element, that is s of I dot CGPA is less than the second element s of I dot CGPA, then it will interchange. The content of s of I is transferred to the temporary variable. The content in the second variable s of j plus 1 is transferred to the position in the first place, and again the content in the temporary variable is transferred to the second position. That is how we sort the students based on the CGPA. So we are preparing the rank list. So once the prepare function is completed, we go to the next function, print rank list. So we have to print the rank list. For printing the rank list, again we go to the function here, print rank list. N is the formal parameter. Printf, the merit list is slash new line slash t roll number. This new line and slash t is for giving a new line and tab space between roll number, name, gender, and CGPA, and between the entered students. So we have the output statement here. Then we have the for loop for I equal to 0, I less than n, I plus plus, for entering the details of all the students up to the limit n. So that is printf slash n percentage %d slash t, and slash t another tab space. We have percentages slash t percentages slash t percentages slash t. That is the roll number, name, gender, and CGPA. So after that, we have to prepare the list of students who have scored CGPA less than 7%. That is the less than 7 points. So prepare B7 is the next function. So in the main program, we have the last function, prepare B7. Here n is the actual argument. So it is passed to the function prepare B7. Prepare B7 is the students who have scored less than 7%. For I equal to 0, I less than n, I plus plus. So it will list out all the students up to the limit, and it has a condition. If s of I dot CGPA is less than or equal to 7, print below 7 list. The below 7 list is, it will give all the details of the students who have scored less than 7 CGPA, and it will end the program. So I have the example output here. Enter the number of students 3. So enter the roll number, name, gender, CGPA. So I have given the roll number 3, Tinu female 8.2, 2 Hari male 4.9, 1 Hema female 7.1. So it will print the merit list as Tinu, Hema and Hari, and below 7 list as 2 Hari male 4.9. So we can just scroll the program once. So we'll run this program. Copy, paste. So it is asking to enter the number of students. I give as 5. Enter the roll number, name, gender, CGPA. Roll number 5, name Vinu, gender male, CGPA 4.3. Then roll number 6, Raju, male 6.4. Roll number 3, Vinu, female 7.5. Roll number 2, Balu, male 6.8. Then we have roll number 1, Somu, male 8.2. So when I enter, it will prepare the merit list based on the rank. So rank number 1, Somu 8.2, Vinu 7.5, Balu 6.8, Raju 6.4 and Binu 4.3. Then it will prepare the list of students who have scored below 7. Below 7 is Balu is 6.8, Raju is 6.4 and Binu is 4.3. So this is the list of students who have scored below 7. So this question is for 10 marks. So next question, what is the output of the program? Question number 16A, that is the, we have to give the output. What is the output of the program given here? So we'll go to the question. So here in this answer, we can see that we have the header file hash include stdio.h. We have the main function integer main. We have declared an array of size 2, that is m of size 2, and also initialized the values to 100 and 200. And we have the variables a, b and c and a pointer variable. It is pointing to the array m. So this pointer variable is pointing to the first address of the array m. And the value of a is assigned to pointer variable. That is the content of a is content of pointer variable is copied to the variable a, and the next position, that is the second position of the pointer variable, is copied to array b. That is 100 is copied to a and 200 is copied to b. And again we have inside the bracket the pointer variable plus 1. So that is 100 plus 1 is copied to the variable c. So when we give the output %d, a comma b comma c, a will have the value of 100, b will have the value of 200, and 100 plus 1, c will be having the value of 101. We can execute this program. Copy and paste. So a will carry the value of 100, that is the pointer in the position 1. B will be having the value of pointer in position 2, that is 200, and C will be having the value of pointer in position 1 plus its content plus 1. The content of pointer in position 1 plus 1. So this bracket, if it is outside the pointer, we can add plus 1 to the value. So this is the position of the pointer p plus 1. So next question is question number 16b. Write a program to read integer numbers from one file and then save into another file. So we have to read data from one file and it has to be saved into another file. So that is for 5 marks. So we have the header file hash include stdio.h, hash include conio.h. We have the main function void main. We are declaring pointer to file f1 and pointer to file f2. We have the variables integer type number comma I. I is the index variable and number is another variable. So enter the 10 numbers in the numbers.txt file. So we have to open a file called numbers.txt file. So it is giving the output as enter the 10 numbers in the numbers.txt file. Then it will open the file f1. So f1 file f1 is the pointer to the file, and it will open the file fopen function. Numbers.txt is the name of the file, and it will be opened in the write mode. So we are opening it in the write mode. Then we have the for loop for I equal to 0, I less than 10, lesser than or equal to 10, I plus plus. Then we have the scanf statement for reading the entered 10 numbers. So we are entering the 10 numbers and we are reading it in the address of number. So all the numbers will be stored in the address of number. Then it will print in the file. The entered numbers will be printed in the file f1. So we are entering the 10 numbers. It will be printed in f1, that is numbers.txt. Then we close the file f1. Once the file is opened, we have to close it. Once the file is opened using fopen function, we have to close the file using fclose function. Then again we open the file f1 using the fopen function in read mode. So we have to copy the contents in the file f1 and write it to the file f2, that is copy1.txt. The name of the file f2 is copy1.txt. So that will be opened in the write mode. So we are writing the contents of file f1 to the contents of file f2 in write mode. So fscan of f1 comma %d ampersand number. That is we are reading the contents of file f1. So the contents of file f1 is read, and we have a condition: the content of file f1 will be read until the end of the file. So the number not equal to end of the file, that is a while loop. The content in the f1 will be read till data till the end of the file. Then it has another condition: if number percentage modulus 2 equal to 0 or number modulus 2 equal to 1, fscan of f1 equal to %d ampersand number, f2 %d ampersand /d number. So the entered number may be odd number or even number. So it will be stored in the file f2. So it will read. So fscanf is for reading from the file f1, and fprintf f2 is for writing to the file f2. So next it will print the contents of copy1 file while fscanf f2 %d ampersand number not equal to end of file, printf %4d number. Then it will close the file f1 and close the file f2. So this is for first we execute the program, enter the 10 numbers. The 10 numbers will be written to the file f1. After that it will open the file f1, read the contents of the file f1 and copy it to the file f2. So we will just scroll this program. We will run this program. Enter the 10 numbers in the numbers.txt file: 11, 22, 55, 77, 88, 112, 554, 632, 852, and 1001. So we have entered the 10 numbers: 3, 4, 5, 6, 7, 8, 9. After that, we have to stop it. Since we are doing it in online C compiler, so it is taking 11 numbers. So we have to give it as, we have to correct the for loop here. I lesser than 10. So next, again run this. I close this. Run this program. Enter the 10 numbers in the numbers.txt file: 10, 20, 30, 45, 55, 62, 78, 96, 32, 4, 5, 6, 7, 8, 9, 102. So we have to stop it because it is an online C compiler. Then in the numbers.txt file, we have the entered 10 numbers: 10, 20, 30, 45, 55, 62, 78, 96, 32, and 102. Then it will be copied to the copy1.txt file: 20, 30, 45, 55, 70, 62, 78, 96, 32, 102. Since it is online, it will be continuously running till the end of the file. Next, we have the question number 17a. Write a Python program to check the largest among the three numbers. That is for 4 marks. This is the comment: Python program to find the largest number among the three input numbers. There is number 1 equal to int input enter first number. Num2 equal to int input enter second number. Num3 equal to int input enter third number. If num1 greater than num2 and num1 greater than num3, largest equal to num1. If num2 greater than num1 and num2 greater than num3, largest equal to num2, else largest equal to num3. Print the largest number is largest. So this is the sample output. Enter the first number, I give it as 85. Enter the second number, I give it as 65. Enter the third number, I give it as 99. The largest number is displayed as 99. So we will execute this program in the Python compiler. Thank you for watching our channel. If you have not subscribed, please subscribe the channel and press the bell icon. Thank you. So when the program is executed using the Python compiler, we get the result as shown here. So enter the first number, I give it as 25. Enter the second number, 36. Enter the third number, I give it as 10. So the largest number is 36. So this is how the Python program works. So next question, question number 17b. Explain user-defined functions in Python with syntax. Write your own function to print hello Python. 6 marks. This is the last question. User-defined functions declaration begins with the keyword def, and followed by the function name. The function may take arguments as input within the opening and closing parentheses, just after the function name, followed by a colon. After defining the function name and arguments, a block of program statements start at the next line, and these statements must be indented. Given below is the syntax for a user-defined function. Syntax: def function name, argument 1, argument 2 up to n, in brackets, colon. Statement 1, statement 2, return expression. The keyword def is followed by a suitable identifier as the name of the function and parenthesis. One or more parentheses may be optionally mentioned inside parentheses. The colon symbol after parenthesis starts an indented block. The first statement in the function body can be a string, which is called the docstring. It explains the functionality of the function. The docstring is not mandatory. The function body contains one or more statements that perform some actions. It can also use the pass keyword. Optionally, the last statement in the function block is the return statement. It sends an execution control back to calling the environment. If an expression is added in front of return, its value is also returned to the calling function. The following example defines the welcome function. This is an example of user-defined function copy. So def welcome in colon. This function displays hello Python. Print hello Python. Above we have defined the welcome function. The first statement is a docstring that mentions that what this function does. The second like is a print method that displays the specified string to the console. Note that it does not have the return statement. To call a defined function, just use its name as a statement anywhere in the code. For example, the above function can be called using parentheses, welcome. The example program is calling user-defined function copy, welcome. Output hello Python. So we have successfully completed solving all the questions. Please like, share and subscribe this channel for more useful videos. Thank you very much.